And now I'm talking about the protein database. One of them is the UniProt database. Okay. So what you can find there, the information is about protein sequence, protein function, localization, and also interaction. So UniProt specifically store protein information. Okay. And CDI database, I know most of you, if you are from biotech or biological sciences or even pharmacy, maybe you take the molecular biology subject before this, maybe you actually heard about the NCBI database. They store what? They store a lot of information. They store DNA, coding sequence, gene, and then information about the intron and the exon, so all part there. And also they have also store protein data. So it's a huge database there, and more complicated than UniProt. Okay, so SBI is a collection of biomedical databases including GBank, PubMed, and also BLAST. So now we are trying to navigate and searching NCBI database. Okay, as I said, NCBI offers various search options for genes and nucleotide sequence, DNA, and also RNA, and scientific literature. Okay, user can access data from different databases within the NCBI platform, and in this database also we can access the tools for sequence alignment, genome browsing, and data visualization. Okay. So, do you know that National Center for Biotechnology Information actually responsible to maintain this database?
Yes.
Yes. Okay, that's good. So now, introduction to BLASTO. Anyone can help me to give the full acronym for BLAST? Yes?
Basic local alignment search tool.
Yes. It's a powerful tool actually in any online database. Okay? It search for sequence similarity between the DNA sequence or amino acid sequence of the protein. Okay? And using BLAST tool, we can compare DNA or protein sequences again in the database. So now, let's say I have found in my sequencing results, unknown gene actually, but I know my species. So I just put from environment, okay, but I don't know which strain. So I sequence the genome, and then once I get the sequencing data from NGS, okay, NGS is a lot, but I just take a portion of it because I want to just sequence the gene. Let's say I want to see the enzyme, hydrolase enzyme only. So I sequence that particular DNA gene that actually translate into the hydrolase. And after that, I use BLAST. Keep in BLAST, and then my one is the experimental. But they have stored that actually hydrolysine from lots of species. So once we search, we do the searching, it will match with the whatever hydrolase gene inside the database. So that we have the similarity. We calculate the software, the database will give us the hits, which is in terms of identity, similarity. So later on we will go and do the practical. So it helps us to identify similar sequences and infer functional and evolutionary relationship. So we can parameter for more specific search. If you know, let's say you are looking for bacteria, then you can put specific kind of bacteria you are looking for. Let's say you deal with human, you just pick human for the class. Okay? Okay, this is covered already. Okay, now bioinformatic tools help us to analyze and interpret large-scale biological data, and then some of them, most of them, not some, has implemented an algorithm to extract meaningful insight, and data visualization techniques aid in understanding complex data pattern. Okay? Different
Oh,
other
other like possible monitor like food
online database.
database, Swisspro,
Swisspro is under Uniprot. Okay.
then KEGP.
That one is for metabolome.
Ginseng.
Genbank is under NCBI.
Yeah, that's
OR Finder, yes, it can be under tools, under NCBI. Okay. So, what else do you feel that will help you tools in the online database? Primer design.
Spassy.
Spassy basically for protein structure.
Yeah.
Oh, this one done. So, just to recap, online database and tools are essential for bioinformatic research. So these are two you have to remember. Uniprot and NCBI actually are very powerful one, and actually is what we activity one worksheet for your e-learning.
Yes.
Yes, sir. Download the class tutorial, okay? Okay, everyone, visit to Uniprot website. This one. Now, maybe you want to look at the, maybe you can put any example down there, APP, human whatever, protein that you want to search. Actually here, right, if you have accession number, you can key in your specific accession number for that protein. Okay, and then click search.
So now you can see that in UniProt it has 216,544 hits when I search APP. Yeah. Okay. Maybe you ask me, what is the review? What is under review? What is the review? What is under review here? When in the context of UniProt, the government have verified. Yeah. Votings are unprivileged. So only 1,448 voting are reviewed. Okay, from here you can see human, rice, Italian mouse, and bovine. Okay, you can look at also the structure. So I click one here. This is the entry here refer to the accession number. Actually, if let's say you want to search here, right, you can put either the gene name or entry number. Okay, both of them can be recognized by UniProt. So let's say when you want to know, you know your specific protein and then you get the accession number, you just click in here. Okay, you just put like this A2 VEY9. Then search. Okay, straight away it goes to this protein. The organism is Drosophila melanogaster. So you can look at what is the function here. In UniProt you can see the functions. And then what is the activity it's involved, gene ontology and annotation. Okay, it's actually a part of a cellular component. What is the molecular function? What is the biological process? This is a new feature in UniProt where you can actually see the structure of this protein, the 3D structure of the protein here. Okay, you can, if let's say you want to study further, you want to do the molecular docking later on, you just can download from here and then do the docking with the ligands. So if you want to get the amino acid sequence, you just can download here. Okay, so and then you can save as TXT file. Okay, TXT file and save it. Okay, this is how we download the. After download, what? TXT file. Because after this, when you want to do the next activity, you need to download yourself, yeah? So remember that you need to download FASTA file and then save it as .txt. Okay? Okay. This is other, we can check, yeah. Okay, next. Okay. We go to NCBI database. So, okay, here in NCBI we can do many applications. Yeah, you can see.
Oh, just high.
So this is a lot of database here. You can explore. Okay, but for today, I want you to look at the DNA gene, yeah, gene. Let's say we are talking about we want to hydrolase E. coli, let's say. E. coli. We search for this gene. Hydrolase. This is example, but if you have other enzyme or other gene, you want can click one of these. Okay. Okay, this is the information about this hydrolase, the RNA hydrolase. Okay, give you gene ontology and then some references about the function. This is the general protein information. So it actually link also to the Uniprot, yeah, Uniprot KB. So actually you can click here and you can go to Uniprot KB. Okay, so this is what you can observe when you get the you search for this gene. Okay, and what we can do now is I want you to download the FASTA file. Let's say first one we want to see more details about this gene. We go to the gene, we click gene bank first. Okay. Okay. So this is from E. coli, complete genome. This is the strain 812 MG1655. Okay. This is all the information about this project. Okay. I want you to look at this gene. Okay. Gene actually from one gene and also coding sequence, yeah. This is the coding sequence. Actually, this is the coding sequence of the tRNA hydrolase of the E. coli. If you want to, let's say, PCR bank, PCR meaning that you want to amplify this gene from E. coli, you have to download this NCDS of this gene out, and then after that you can use the PCR primer to design the primer when you input the sequence into the tools. Okay. So now this is the translation from the gene. Okay. See, it gives you in the gene bank. When in the gene bank, it gives you two information which is very useful. The first one is the CDS, also gene, we call it as gene, okay? Coding sequence and gene, and also the amino acid sequence. Translated amino acid sequence. Okay. You press gene, what you got? So the same here. Okay. Now, how to save? How to save? Right. So we just go to FASTA file. Okay. Now you can save this. Okay. Send to file. Things good. Everyone okay?
Yes.
You're okay. Okay. Now we do the sequence analysis with BLAST. Okay. I want to just use this one. Okay. I use the BLAST from NCBI. There is also BLAST tool in Uniprot KB. Okay. Okay, this is the BLAST. Okay, the BLAST tool in NCBI. Okay, I hope everyone can get it familiar faster. Okay. Now I teach you how to do nucleotide to nucleotide BLAST. You want to do? Why we want to perform BLAST? We want to know the sequence, similarity of the sequence, right? Okay. So now I have already my FASTA file previously from the gene, right? Okay, where is the download? And then, because let's say I don't know what is the database that I should use, usually I just make it an R database, redundant database, okay? But if let's say you know the organism, you can put here, add organism, if you know that organism that you want to. But if actually you don't want to specify the organism, is also okay. Okay. So we optimize for highly similar sequences. Okay. You can try also after this to see the result if you click more similar sequences or somewhat similar sequences. Okay. So, okay, and then last. Okay, now we got the last result already here. So you can see here, this is the important one here. The percent of the identity. Okay. The E value should show us the significant lah. P less than 0.05. Okay. And query, the query cover meaning that from that sequence that you put how many that actually hits sequences in the database. Some of them may be only 80, some of them may be 70. Okay, not say, but here from E. coli you can see 100%. Okay. You also can do the graphic summary here, alignment, this one. Okay, so here I want you to focus on score, yeah, aspects, p values, identities, gaps, strength. Okay, you have to, in order to analyze if 0.0 is very, very significant. Okay, identities here. Okay, 100% for DNA, 90% above for DNA. Okay, should indicate it is from, it is, the hit is really good and high similarity. Okay, so that 100%. Gaps over here because it's 100% similarity, no gaps. You see. So let's see if we have gaps. Everything is 0 in gaps. Let's say, how should I, later on I show you which one is the gap, but this is because we obtain 100% identity, so we don't see the gap. And strength, plus minus, everyone?
Yes.
Plus minus indicate what?
The reading from the 5 to 3.
Yes.
Minus is
Okay, in DNA, it has
two strands.
double helix, right?
Yeah.
Strand. 1, 5 prime, 3 prime, another one.
3 5 complement strand.
Yeah, complementary strand. So now, plus is what we give. Give input, our input to this database. Minus what they have in the database. So it's complementary, plus minus. If you get plus, meaning that it's same, it is same strand. But if plus minus, meaning that it's complement.
This is the one plus and minus.
It's okay. Plus, plus also can, plus minus also can. But when you want to do further analysis, when you extract the FASTA file, then you have to bear in mind this is actually is complementary from the database. Okay.
And then
That's when I get the gaps.
shorter
Mm.
DNA sequence.
Oh, the E value very high.
See? Percentage is really using 95%, but still from E. coli.
Yeah.
Yeah. Right. So now I show you the gap. This is the gap. This is from our. This is query is from our data, and query is from the database. So in our query we have 3 gap here and 1 gap here. Okay. So that's why. But if let's say
Really?
you get this one or this one is just
Wow. So there's no standard, we just base.
but actually the most important thing in class is look at here. Identity and query covered. Okay, and also the score. And also the score. Okay, here score, identities, 95%. Look at the gap as well. Because some of us maybe want to see the mutation, that's why you want to see the gap. Right. So that's why it's important to understand. For class, I think we cover later. What are the algorithms for class? Okay, that's the formula. We will insert that one. The algorithm and come out with the score. Okay. Like, you know, they have this is your data. And then when we search how many of your sequence actually are aligned similar with your sequence in database. So how we calculate that one? We apply an algorithm and we come out with the score. That's why it comes out also with the statistic value. So does it know? Yeah. Yes. Usually I'm looking for the identity. Okay. Okay, everyone.
I guess another little fact.
Okay. Yes. This is often get like this, but look at the percent. The highest one would be your. Okay.
So we see the list.
Okay, everyone. I think we finished activity 1.
Yes.
Activity 1.
Activity 2.
Activity 2, done. This one maybe later if you go back, you want to, explore more, then you can, I welcome you to try all of these tools. Yeah. Okay, now we continue to SQL alignment. SQL alignment. Actually, it's associated to the block. MSA. Okay? It's a method to align 3 or more biological sequences such as DNA or protein sequence to identify. Just like last.
It's now the blast. So consider pairwise aligned.
And then, but for MSA, we want to align more than one sequence.
More than 2.
More than 2 lah. Okay. So that's why we do multiple sequence alignment. Okay, it's really help in, we use it to understand the evolutionary relationship between sequence, predicting functional regions, and identifying conserved motif. Okay. What's the importance of MSA here? It's a really play a crucial role when we doing comparative genomics, which enable us to identify conserved region across species and understand the functional implication of genetic version. So meaning that here, okay, let's say you want to see mutation that relate to certain diseases, cancer diseases, like that, SMT, you get a single platform for disease, right? So you will align like between stage 1, 2, 3, 4, and healthy, and those genes that related to cancer. And you know that this mutation will lead to aggressive cancer. Okay, so that's why you align this gene together, so that maybe in healthy individual it doesn't have this mutation, but if let's say this patient has this mutation but no symptom yet, it has a potential to get the cancer. Okay, something like that. This is why this analysis MSA is important. Okay. Okay, it also helps us to discover potential drug target, designing primer for PCR experiment, and predicting. Okay, when we look at the protein structure, sometimes when we have the mutation in the sequence, the amino acid sequence, the structure will be not in the original in native form. It will turn. And when it structure changes, it will change the functions of the protein.
Okay.
It's just like isoform.
Yeah. Doctor, can I know what is conserved region?
Okay, conserved region like in one species. This sequence is supposed to have this sequence, TGTA, and then this RNA sequence should be across all chromosomes must be the same.
Oh.
That's why we call it conserved region. Okay, in conserved region sometimes they conserve the same function.
Is it the same as conserved domain?
Yes, sometimes we call it the term conserved domain. Okay. Oh. Did you know MSA what we use in phylogenetic analysis?
Yes.
Yes. Who know? Who know about this? One? Raise up your hand. Who know that MSA used for phylogenetic analysis? The rest? Okay, basic concept of MSA or homology. So you need to understand what is the term of homology. Homology refers to similarity between sequence due to a common ancestor. Okay? Conserved region. This is your question. sequence segment that remain unchanged over time and represent functional elements. Okay? Gap, a position in the alignment where one or more sequences have insertion or deletion relative to the others. This is I call it as a mutation. Okay. Types of MSA, global alignments. Okay. So remember this term, global alignment. Okay, align the entire length of sequence including gaps. Okay. That means if you have a gene, okay, a gene, if you use global alignment, you align them from ATG until the start codon until the stop codon, TAA. So you will align them. If, okay, let's see. The second sequence also, you will have the same line as well. From ATG to TAA, same line. So you can use global alignment. But local alignment is only aligns highly similar region of sequences, allowing gaps outside these regions. And progressive alignment builds an alignment by adding sequence based on the pair distances. But actually, in our case, we always use local. Which type of multiple sequence alignment align only the highly similar regions of sequence? Local. Good. Oh, this is I thought previously. I just discussed with you about the pairwise alignment. Aligns two sequence to identify region of similarity and calculate the similarity score. It is the basis of MSA method and help in understanding evolutionary relationship between sequences. Okay. Tool for pairwise alignment, of course, BLAST and clustered omega. Later on, we will try to explore clustered omega, okay, or cluster W. Okay, BLAST is used to find similar sequences in large database, while cluster is versatile tool for MSA. So you want to explore more about MSA, right? So later on we will go cluster W. Would you rather use BLAST for sequence search or clustered omega for MSA?
A and B also.
Okay. Okay, example of pairwise alignment. This one like what? Like the subject, right? Okay. Here is an example of pairwise alignment using sequences. This one and ATG, CTAC and ATC, TADC. The alignment reveals the presence of a gap indicated by dash in the second sequence and highlight the conservation AT in both square. So this is you have done before, right, with me in the class tutorial. Okay. Okay. MSA can be progressive alignment. Okay, use an alignment by adding sequence based on their pairwise distance. Iterative refinement, align sequence using an initial alignment and improve by it adjusting gap and introducing consensus sequence. And either Markov model uses statistical models to align sequence based on probabilistic assumption. So this is the method how they perform MSA. Okay?
Even now.
Either Markov. True or false, yeah?
False.
Either Markov are used for progressive alignment?
Yes.
Just now, yes. Okay, application of MSA. You want to build your own phylogenetic analysis, infer evolutionary of your species sequence. Okay, you want to study the functional adaptation by predicting region based on the conserved region, and for drug discovery, when you want to target your drug to the conserved region. Okay. Summary and review. MSA is a powerful tool for comparing and analyzing biological sequences. It helps us to understand evolutionary relationship, predicting protein structure and function, and identifying conserved region. By MSA, we can give valuable insight into the genetic basis of life. Okay, so activity 2. So now, everyone, get the worksheet for activity 2. MSA. Okay. They define, describe different type of sequence alignment, identify the component. This one I already discussed with you. Perform or basic sequence alignment using bioinformatics software or online tool. So everyone, if you want, okay, you can go to this cluster omega in the. But at the same time also, I think I'm installing BioEdit over here. BioEdit. No, tak.
That's the software?
Yeah, I installed already the software here, BioEdit.
Oh.
But last year, but I don't know this year. Whether it's still here or not. No result. So I need to website. For this time, I want you to do first, and then after that, I would like to now to go and see one by one.
Okay. But the internet very slow here.
Yeah, you can use this one if you want. My one. You can be a teacher here.
No.
This is peer.
No.
Okay, you can put DNA, you can put DNA or RNA or protein. So this is what? This is DNA or data or protein?
Sequences. All like that. This could be fake.
course, maybe the
You recognize something? I think I don't know. Sure.
you all can try this one.
SB.
Yes. Yeah. You all can try also example from this database. I think because of this
I think because the space bar here, right?
Oh, because of not. You can try lah.
I think it's because of the space bar. This space here. Working.
You.
Yeah, space.
But you can learn more than that, yeah? More than 2.
What's the X?
That's the W. That's the X.
Okay.
Yes. Okay, now. Okay.
So.
This is okay. We want to see the live result. Yeah? You can see here. Doctor. Yes. Huh? But
You have to remove the space between the sequence 1 and sequence 2. If between the word sequence 1 and sequence 2 there's a space, then just remove.
Space.
yeah.
Yeah, I think it depends on how you read. 因为你这样没有 I think it's 它的那个
这样然后呢？这样然后呢？不是应该提交吗？啊是，这个。啊，这个样子，说为什么出问题？
Okay. This is why they give us like this. Okay. Now, actually, the start in consensus of the sequence. Let's say A, consensus is A. T, consensus is T. But here, it cannot give you consensus because one is T, one is A. So if you are looking on the conservation essay, you will find it in this area. This area, right? This area. If you are looking for the conservation, but if you are looking for the mutation, of course, lots of mutation here, right? Here.
But we copy the same sequence that as you state in the
worksheet.
activity now. But how comes the difference?
Maybe your one, your just
Copy wrong.
Copy wrong. But it's okay. You can try from ADIAC just now, like here. You can try. Yeah. Okay. We go yes.
Yes.
So. Yeah. See, Okay, if I want to, it depends on your experiment, my students. It depends on what is your objective for your experiment. Let's say you are looking for mutation, insertion or deletion. You want to see something like this, right? Differences in the DNA sequence, in the bases. But let's say you want to study the consonant region. You will look at the region that have a long stop.
Oh. Okay.
It's okay, later on we will do more of this. This one I don't know. This one like cannot read. Oh, I really don't know. Okay, the dot here, okay, shows no consensus. This is consensus. A, stop, consensus A. So they put stop. But some of you got dot, meaning no consensus. But here gap and align. Gap, no align, and align.
Oh, okay. Maybe you give him PDF.
Again.
The computer display different.
It's okay.
There's still some more here.
Yes.
啊，我知道了。Distance space method. That's just mega X, right?
Depends a lot.
Wow, okay.
But I'm familiar with parsimony method.
I'm familiar with mega X. My project.
Depends on what kind of experiment.
Next time to analyze this tree, Java tree. 我知道为什么一样的，它那个对啊，PDF 格式，白痴。没有，我的电脑才是对的，电脑才是对的，因为有90多个啊，你们才弄60多个，也奇怪，怎么有90多？
得开热点。
那个 display
开热点，我看一下是什么。
哦，有点的话就是
这个电脑不会开，这应该有。不对啊，不是只有手机才有热点吗？有，你找。
我们看它的，alignment 就是你只把这两个放在一起做比较，比较 alignment。
不是 WiFi 不能有热点吗？
它的 consensus 在有没有放一个 region 出来？这个一个 star 这里就叫做一个 consensus。So 如果它还有很多个地方一连串一直有 star 的话，就代表那个地方是。species 还是 strain 的，都是一直重复一样。即便讲你的口音后面有 modify， 它也不会改前面的。
我发不过去。
后面的那个 string 可能就这边会有 deletion、insertion 还是什么。
它分不了。
前面这里的是什么？所以 it's useful 咯，它是如果你要做到 drug discovery 的话，然后打给这个 C 还是 D 对上。他的意思这样讲。
如果这个就是他点点点就是他，
点点点就是他没有这个这一排，你看它有69嘛，这边代表多9个，多9个，多9个 这边sequence 2对不对？他们有这个，对，就60个了，后面啊，对，有 copy 完的，那个是那个图片相同，不是信号出现。你看信号两个都是一样的，可以去这边看，快入。现在这个只有2个，对，他们不了这个，因为那个是画，也画出啊，画出。那如果你某个的话，它这边就会显示出来，那你这边有30个sequence，它就会帮你排1、2、3、4、5、6哪一个是最靠近城市6、7、8、10、12样子是最靠近剩下的2、3样子。这样你可以从中里面得出一个结论，就是说，这是第一个，第二个是相近，是比较有一个共同的组件，可以解一个进化出。可这个不太准啊，等下老师我们教，我们就会用一个词进去说。以前我老师用什么软件？以前会用。我没有用。没用过。我爱你。什么？我没事啊，不是中国人。啊，原来是中国人。他是荆州，是荆州，精神上的。是罗马，出生就是罗马。我专业的历史会处理的。第二个好像北大还是。这个网站是 Dream Plus 嘛？是 Plus 上那个上，那你找到的啊 ？Plus 上面你可以说报价那个不都是人进出版？对啊，哦，那个我是大概就是找那个蛋白质的，因为不知道找蛋白质的东西，找那个资料。因为多少次？还有哪一个？君丹是这个吗？拉钩。
对，就中间那个。这个 ，plus 这中间这个。
我真机贼慢。
这个是干嘛？
这个去找啊，一个你要的一个基因或者是蛋白质。
你给我看一下。
在数据库里面你可以找。
please 演示一下。
啊？
演示一下。
要演示咩？这个自己去找而已啊。
我不会找不到啊。我有那找到，早就找到了呀。
啊？随便找一个啊，你喜欢什么蛋白质你去找啊。
没找到，我都没找到那个网页了。你可以直接打开啊，那个网页，刚才那个。这样打开吗？
国际版，国内版。你们上谷歌要翻墙
啊？现在不翻给你，原来要翻。
This is space vector, just like I'm familiar with that. I thought we did try to analyze this. As a pastor, I always did do it. Yeah, you know, that's a poor girl because I take my good care. 这是什么啊？
他那个录音，
他录音怎么给你翻译成这样？
所以我就叫我看看。
你要找什么蛋白？
哦，就从这里。
啊，不是，你要缩小你搜寻的范围，这里就可以缩小。你要找这个书也有，你要找基因也有，你要找整个基因组也有。
选基因我
要找蛋白质。
选基因看一下。
你要找菌，要找什么菌？
哦，然后就输进去。
要找什么菌？分蛋糕。
是就有
不能随便找啊！你要怎么
不能吗？
随便找一个？
随便啊。这什么玩意儿？
这是帮你调节你体内的糖的那个荷尔蒙，叫什么？
罂粟林那个胰岛素
胰岛素对，
啊，
要去找，
然后就点它。
点啊，点了就找到了。然后说你要找胰岛素的，胰岛素有很多啊，你就找到了。
然后是怎么看？
从这里找呗。胰岛素的什么资料都有啊，这里，人家文献也有。可是我不会找 gene 啊。如果你要找它的基因，它的那个排列的话，你去找这个。有可能找胰岛素。胰岛素的基因排列，就找这里就有一大堆这个人类的，对，就这样。基因排列那么多，胰岛素那么多，那么长。
Thank you, thank you。
这些你还看得懂？什么？读书读得少，表现很好。重点讲找基因的话，找的是不想找基因，看你要找什么东西。真的很复杂，给很多东西。你看什么给？我喜欢去找这个，如果你要直接一点的话，直接去找那个历史版的。可能这些，然后再做点那什么 hydrolysis， 180哦。然后你可以缩小那个范围。后来是细菌。动物病是说原来是有大病的，是说。不是，你后来不晓得名字。这个我准备，一直到2个，对。例子，大概。后来。杏花是吧？已经是一个树。它也是有花，这个花语是什么？B。真的是说。熬银 ，OK， 好是。银是什么？什么？银是什么？银是人。哪里？ 男女。那你跟我说，这样的
你是可以领取的。
我操，这买这么贵，这是好，我看你这儿茶拍卖60块，那分多了。这里的茶还是真大，我操！跟茶拍，别气，别气死，哇！那怎么好啊？好，一边追。网友有没有跟我说过，他不能从歌之王，他只能拿一边去追。罗马人喝的水。我们说中文。我们说中文。我爱冰淇淋。早上好，中午。早上好，中午。我爱。早上好。早上好，中午。中国。对。早上好。
这什么意思？为什么？
我爱冰淇淋。I say good morning China. I love ice cream. 啊，肯定。早上好，中国。我爱冰淇淋。这是一个谜吧？手机拿。一个如果有1000热的话，在这上面对，就看平均点。对。
并且说完。
没有啦，这样平均点完全不好。如果你看什么意思？
No, that's not wrong. So, go back. That's. We are not considering the score. We are looking at the consensus of the sequence. Yeah. So that's no way for me to look on the score this is.
还要宣传他的电影，反正还有跟什么宣传？早上好，中午。现在我有冰淇淋。
你为什么要先有冰激凌啊？
看不懂。这是一个谜语。那中文
Yeah. Yeah.
还有别的爽快的事情，只有这个把手可以让。可以try这样。
Everybody can we continue?
Yes.
To the next subtopic, phylogenetic, molecular phylogenetic. So in MSA, actually, we didn't get the score, but we get the consensus of the sequence. If you are looking for insertion or deletion, you look at the gap. If you are looking at the base changes, you see in cluster omega here, you see the dot. Okay? But if you want to see the Poisson region, meaning that you can see the star. Okay?
Ah, this one, Maudali.
This one you can use.
This one, very easy, this one. Some more things you can see. So let me see.
So try many online database too, yeah, for MSA.
Last time I used this MSA. Start.
First, we use data from DNA, acid, as well as amino acids. Good for the protein. That's why it's called molecular phylogenetics. Okay. Molecular phylogenetics often used to study the phylogenetic evolutionary, okay, relationship using the molecular data. Okay. It involves analyzing DNA, RNA, and protein sequences to infer the evolutionary history of organism. So it's like this. Right. It is a carrot, but different color. It's evolutionized, from the original one. And until where colors, many colors here. Okay, something like that. Okay, phylogenetic tree also used to represent the relationship between different species or groups. Next. So, evolutionary relationship. It is important for understanding biodiversity. It provides insight into the common ancestry because we want to study who is our ancestry or what is the ancestor of the species nearest and their divergent evolution. Okay, evolutionary true or false, evolutionary relationship have no impact on our understanding of biodiversity. False. It has significant impact, right?
Yep.
Okay, molecular data that use can be DNA, RNA, and protein sequences. Okay, they are very valuable because it's about the genetic makeup and also evolutionary history of the organism. Molecular data is more objective and less affected by external factor compared to morphological data. Have very advantages and disadvantages. Sequencing is traditional method while NGS allow for high throughput sequencing. NGS is faster, more cost effective, but may shorter read length and higher error rate. The single molecule sequencing such as PacBio or small nanopore and offer long read but lower accuracy. Okay, so this is how we get the DNA or genomic sequence by DNA sequencing. Okay. Phylogenetically represent the evolutionary relationship between species. Okay. Why tree? We look at the structure of the tree. We have root,
Trunk,
trunk,
and branch.
branch, stems, right? So now, branches represent the lineage of species, while nodes indicate points of divergence. Is measure the genetic distance between species to infer relationship. They use algorithm like neighbor joining and upgamma to construct trees. The strength is fast computation, useful for large data set. But the limitation here, ignore evolutionary models, assume constant rates of evolution. Okay. And then maximum parsimony method. Two or more method here later on. Okay. So analyzing, when we use this method, let's say I choose parsimony method and construct my own tree already. So now from the tree, how I going to interpret it? What data that can I extract from the tree? What information that I want to see, I want to observe, correct? Okay. If phylogenetic tree are analyzed to understand the evolutionary pattern, infer ancestral sequences, and identify key evolution events. Actually, they are used in various fields, including conservation biology, drug discovery, and evolutionary biology. Now my question here, how important do you think molecular phylogenetic is in conservation biology and drug discovery? How important is that?
Like evaluate how important is that?
Yeah, how this analysis actually lead to to discover new drugs, to give impact on the conservation of conservation of biological species. So how is that? The application here.
Can you see?
Like to know the origin of our data that we inform, so we can use it for the conservation biology and drug discovery. With drug discovery, because each drug has a base, so we have to know a base of the data that we get from the genomic or proteomic. So in that way, it's help us with how to deal with it.
Remember that for drug discovery that we're going to analyze the conservation,
Yeah.
the conservation in the yeah. So we are looking for that, and then maybe we want to study the efficacy of the drug. If let's say in the phylogenetic tree from this species, let's say they are this strain, they are they are in the same branch, in the same cluster. So is it this drug can affect this cluster or not? Okay. And conservation biology, of course, is very useful because we want to know about the biodiversity of the species, to understand. Maybe you can give me example in conservation biology if you are from biological sciences background.
Like study, I know tiger maybe.
Yeah.
So between different region of tiger, then and use their collect samples and then analyze with
And if let's say looking at the snake species across globally, and then we can sting. Okay, it's a lot of things lah. Okay. Okay, activity number 3. Our last activity for today. So I leave it to all of you. I will just go around, and if you need my help, okay, just raise your hand.
I use computers.
Can. And also I have in the e-learning platform, if you want to refer to the parsimony method, e-learning. I have upload a video on how to construct your own parsimony method, so you can refer to the video. Okay, but in the worksheet actually, it's not parsimony method, it's other method. Because you need to do the first step, you need to get your DNA sequence. Okay?
Let's
Ilan? This one. Not this one, put it for next week.
shows the growth of organic plant, right? Still collect the sequence of children.
Align first.
So where do we get the sequence?
You need to go to NCBI or Uniprot.
Okay.
Okay.
Oh, okay, and then we
Actually, my tip here, you want one gene, okay? Just start one gene, okay? And then once you blast the gene, you will get a list of related genes, right? Now you can tick a few, maybe up to 10 sequences that showing in the blast, and then save it as pasta file and use it for your MSA. And parsimony method. But that one is using the protein sequence. And I will use the bioedit to construct the phylogenetic tree, but it seems like the bioedit is uninstalled. So I
Need to install the software, right? To use this.
previously it has. I already installed it here.
Maybe I use Zmaze.
But so means just follow the worksheet. Okay? And also you can watch my video in the e-learning. This is mRNA.
Yep.
That's okay. That's
DVT again.
get your blood and so you can maybe go there. Go it down, please. Maybe click the first one.
This is the
Yeah.
this is the one I find.
Okay.
Where compared to this. So this longer.
No. You just open one first and then I'm gonna that one.
What?
Just click one. Okay. Go down. Okay, you can actually download.
Oh.
Download. Actually, you can go. This one download one by one. Actually, you can download all together. Okay, you go to the front page.
Sure.
Yeah. Here is the tick one. Like the tick. You can just tick. Maybe 8 or 10 first time and tick meaning that you
The one.
the one. Tick and one.
So many. Maybe I think just the one I want.
Yes. And select all and just tick what you want first.
And just put the horizons of you. Download.
Not alignment. Faster sequence first. Faster sequence. Maybe do step by step.
Okay.
Okay, you got all. Okay, that's good. Save. SCSD.
Oh. Wait. Save that.
Look at the worksheet. So where you should go?
Worksheet. Where's the worksheet? I closed out just now.
I think I put in front already. Stop. Wow, phylogenetic tutorial.
Where?
Okay. Then, okay now, you can align using the DNA cluster
It's actually called Mao Align. But I call Mao Darlene. Very slow.
How itu cannot? You should select 5, 6, 7. Okay. Oh, you cannot give for this kind of word. If you want to put down the file, you need to put it in one file, all the sequence. But if let's say like this, you need to copy paste one by one.
down 去哪一个啊？down 去 faster complete sequence
Complete.
complete sequence faster complete 啊。
So what is the key that you want to get? Okay, so you select, you pick a field, or 6, 7, 10, 14. Actually, you need to do plus first. Plus first, then do plus. You get already. So how you are going to proceed? Using MATLAB to find the history? Because
Then you ask to use the
cluster, because cluster means you can construct directly the tree.
oh yeah.
Maybe active ACCIN. Right. Oh, because you search for the search for so they are running for you, right?
Yeah.
Okay, he got already.
看你要哪个啊？美国。
Okay, the first example already here. So you should get something like this. I think you all start on the last right. You have to save all the sequence in Wi-Fi. Can you show them?
Okay.
Okay, everyone. See how from the last how you can save all your sequences in Wi-Fi.
Okay, very easy. So once you got to this page,
Blast.
right, you blast already, you got to this page. Okay, so it will show you this tick everything here. If you tick everything here, it actually means you select all. So you just choose something randomly or you're interested to look at, then you download this, start complete sequence. So you already got the sequence, you want to do alignment on that, right? So you just use, so it's downloaded already, it will be in a TXT file format lah. So after that, you go to your multiple alignment tools. It can be Cluster W, Cluster Omega, and then you upload the TXT file that you downloaded just now, and then it will do this everything for you. So once you reach here, you already did the multiple alignment. You want to use the philo, you want to construct a philo tree, you go to here. So you can choose, to the very end, you can choose this one. You want to philo ML or Rex ML.
You can try both.
You can try both. I think Bootstrap will be more accurate,
所以
right?
我觉得这显示什么？
Actually, I think Bootstrap will be more accurate. Because Bootstrap consider what's value inside.
Okay, I think you all start. How to save sequences of the person for Wi-Fi.
为什么我点开是这么个东西？为什么我点开是这么个东西？
你点开了是这样子的，你点了啥？
我跟你点的一样。
你跟我点一样。可能这个 data 太长了。像
我跟你选的一模一样。那看一下往前的话，你选的是哪个？
我选的是往前啊。
对啊，我就是点了。
哦，你在这边不要点进去了，你就在那边钉。
哦，这样子吗？
然后你就 download， 然后你就下载。下载在哪里？你个孩子。
好问题。
OK。
它这样怎么下载？
给它变长了。
可以。
怎样？为什么我做不到？
直接放到。这样可以吗？
下载在哪里呢？
啊，算了，我现在试试。
为什么你的？
它这好像跟那个不一样，它这个不是，它这只是那个，它只是搜索还没有 blast。
哦，你还没有 OK。
对啊，我只是搜索啊。
按进去。
对啊。
哦 ，OK。
我进了。
OK， 这就是你进来的位置。
我也找不。我是不是应该搜那个什么 genetic 不能搜 gene？
你现在是在 gene 哦，你在 gene， 我觉得你应该要想 nucleotide。
哦，就这样不行的话，只能搜那个。
上面，我也不是很确定，你按看吧。再搜。
是这样吗
？N。
啊 ，N。
那个 N 不是 F， 是 N， 两个 L 呢？
啊，好。不一样啊，这个意思。
gene 跟nucleotide还是不一样啊。
这个是啥意思？基因序列的意思。
这个不知道是什么动物的
就是这个。
nucleotide 是基因序列的意思。
哦。
然后你就可以有这个。
我就说我为什么搜不出来啊？你再试一下。
That makes sense.
What?
Right.
Oh, very good.
Correct. 是因为是加重。伟大。
震惊世界的伟大发现，我操！
就是它的那个 value 啊，不用它给的 value 是，它一个 p value 是什么 value 的？
哦，所以这个比较近，所以它在一起。所以这个比较OK，懂了。
好像是这样的东西。
这个跟这个没有也比较近啊。现在随便0.00，我都不知道什么。
是它的一个 value。
两个是一样，我不知道。
你可以去找，其实用 Bootstrap 的比较更接近，来 understand 这个东西。Bootstrap。What is Bootstrap? In Philo, say that what is Bootstrap in Philo? 我去找一下。是吗？对啊，很接近的。我不是 join 他们的，我 join 外面的。我去找是 Bootstrap， 所以就 better understanding 它那个 value 是什么意思。
它这个需要先变成 mRNA。
你需要把它
Bootstrap solo
不需要，你要 download 它的 FASTA file， 因为你这个它有那个号码在旁边，你刚才看到吗？看啊，再回去刚才回去这个啊，你看啊，它这个还会告诉你，你这一个是第一个基因系列，然后到这一排的时候它变成第61，所以你不要这个东西，你要它的 FASTA format，因为你等下要 blast 的时候，你不可以有那个号码。
我也说。
所以你就这样。
Ctrl C。
然后你就要去 blast。
就是这个也是。
就是这个。
Yeah。你把这个删一下。
所以这个不行哦，因为你1、2、3，所以你要，所以你有了过后你就爆炸。哇，原来 blast 的话也叫爆炸。
对啊。
好可爱。OK， 爆炸 OK 可以在这边。
不要一定。
我没有撑着。
哇，好重。
这一个，比如说而已啦。我随便啊。然后你就可以 download 它的 FASTA complete sequence。你 download 了过后呢，你就可以来到你的。
来，咱们直接 download。
OK， 直接 download。
然后是这个。
去哪个？这个吗 ？OK， 来到这里了，那你就要回去 home page 吧，这个已经 search 过了。哈哈 ，OK， 你 delete 掉这个东西，你删除。
你点进去再点 Enjoy， 再点开 Enjoy， 就是。
选择文件。OK， 刚才download在哪里？不知道，
我也不知道。
应该是下载吧，
下载。
我第一次看到华语的。OK， 打开。
是这个。打开。
OK， 好了。
上面要不要变 DNA？
Submit。
你是 RNA 还是 DNA？RNA， 那你就看 RNA。
这个为啥是 RNA 啊？
我刚才搜的就是 RNA。
我刚才搜的是 RNA 吗
？mRNA， 你刚不是看没写吗？
哪里写啊？我没看，我也没看。然后就点这个啊。
A long time. OK。是你的答案出来应该是说差不多。OK， 有了哈。你就画上去。 然后你去这个
这
tree，
哦，对，还在选这个。
然后等等 ，good。
哪里写的是 RNA？哪里哪里写的是 DNA？哪里写的？
选择不一样的。
你刚才下的时候就是下的
我没看到啊。
是不是就 mRNA 吗？你下的时候
这儿好，mRNA。
这个
啊。
没有，但是我觉得哈，它就算是 mRNA，它也会帮你
翻译过去。
翻译过去，因为 DNA、RNA
不一样
差一个 U 跟
啊，
T
对，
所以它应该会帮你翻过去吧？我
但是
觉得它
它这个
应该没有
是短的呀
笨。
，DNA 应该会长的。
是，
对，它那是诊断。对啊，DNA 你是诊断的，mRNA 它是
少了一个
功能查不出来。
哦。
mRNA 是你
哦
断翻译出来的。
所以
不转
我
过来
们现在只是用短的来试试看就可以了。到时候你还再用它，因为现在我觉得网线也不能支撑你找这么长的 DNA。
那是啥？
我没听到。
你是啥？
那个是要试的流程。
他讲说，如果你要试的话，你不要用这么长的，因为现在的网线不稳定。讲说，如果你想要 try， 你可以用那一个 troponin I disaggregate 的那个的那个 G 的 DNA。
姐姐真猛。Thank you。哎，没事儿，都是姐姐。
我妈的，对不对？点这个。这个也有可能下面可能会表示不知道，不知道哪里。就看你谁都然后这个又这样才会在测出来。
还有这几个。稍等，稍等。喂，不是。
最快的。Yeah, the distance, the node,
The distance.
branch node,
Branch. So the farther the distance, actually it's not related. No?
the less related.
The less related. Yes, less related. But if let's say it's in one cluster,
They have share the same branch.
Yes.
这个有挺重要的。
Some of your phylogenetically may have the distance value. Okay? Depends on the
对吧？
software that
什么
you
意
use.
思？我要
Looking at your protein that you are targeting, maybe let's say one target one is fine. This one protein of the virus part,
先过一遍流程。
应该是你的吧，对不对？
随便选一个。
你说的。So 你选过后，然后你还去 Fasta 吗？还是直接走 Blast？
应该是 Fasta。
如果我直接走 Blast，
是你们有
不太清楚。
为什么不能直接走 Blast？是不知道，它是一样的嘛？它 Fasta 过它是一样用经历这个。
刚开始我是读了一脸懵。
他到哪里去了？
我读不懂他到底是什么。我弃教了我的那个毕业论文，就是去。
你的出得来。
那时候
你的出得来。
那就这样，那就这样。
就是 select。
可以直接 blast。那我绕了半天绕了个什么？
所以我的电脑有问题喽。
所以说不要买华为。
烂华为，退货。
华为手机可能还可以，但是它电脑肯定不行。
真的呀？
真的呀。
对，我本来要买 Dell 的，你知道吗？然后买 Dell 的戴尔啊，
就是
那
第一个。
边的戴尔，这个吗？好了吗？
戴尔好像也不咋地。好了，已经好了。然后就进那个 什么 MU 那个对比那个。
这个嘛，所以我就直接 copy and paste 嘛。
不用直接